Hello. In this video lecture we are going to study band pass filter. So we have discussed low pass filter and high pass filter. Low pass filter allows only lower frequencies, high pass filter allows the higher frequency. In both cases we have to mention the cutoff frequency. In a band pass filter it will allow a band of frequencies. Okay, so there also we can have two types here. Two types. One is wide band pass filter. Another one is narrow band pass filter. Okay, so the general response of band pass filter we know. Usual response will be it will allow so there are two frequency FL and FH, and you will get the frequency within FL and FH are allowed, and the frequency outside this range they are attenuated. So here wide band pass filter means it depends on the bandwidth. So wide band and narrow band, usually it is described using a term called quality factor, Q, quality factor. So it is also defined by like this: Q equal to FC divided by FH minus FL, where FC, this is C, is the center frequency. So if we calculate for a given band pass filter, if you calculate what is the center frequency means where the maximum will be high. Okay, so that if you calculate and if you find that Q is greater than 10, if you find that and Q greater than 10 means it is narrow band pass filter. Okay, so and if Q is less than 10, then it is called wide band. So it depends on the bandwidth. So if the bandwidth is very narrow, you are very selective in picking up the frequencies, then it is called a narrow band pass filter. Okay, so we will discuss wide band pass filter in this video. So let us consider wide band pass filter. Okay, so you can realize a band pass filter using or by cascading high pass and low pass filter. Okay, and what is the roll off you required? Depending on roll off, order of the filter is chosen. If minus or plus or minus 20 dB roll off you want, you select first order high pass and first order low pass filter. If you want 40 dB, then you go for second order. Okay, so let us consider first a wideband filter with 20 dB plus or minus 20 dB roll off. Okay, so how it is decided? You can concatenate or you can cascade two filters. One is HPF, another one is LPF. I will explain how it will select only band of frequencies. So first let us take high pass filter, where this one we will call RF and R1 grounded, and high pass filter, that means first should be L and then R. So sorry, C then R. This is V in you are applying. So this is a high pass filter, first order high pass filter. Okay, now you connect this one to a low pass filter. We will call this R dash and C dash, and it is connected to an op amp plus minus, and this is minus, and we will call this one as R1 dash RF dash V naught. So this is first order LPF. So up to here it is high pass, after this LPF. Okay, so here if you consider response, if you consider the response, so okay, so if you observe this one, if you observe this half, you can, if you consider the response looks like a high pass filter. So this part looks like a high pass filter, and after this if you observe only the lateral, this one second part only, if you observe, it looks like a low pass filter. So a high pass filter with cutoff frequency, F1 if you take, a low pass filter with a cutoff frequency F2 if you take, then it will, and if you add those two, you will get, if you cascade those two, you will get a band pass filter with bandwidth F2 minus F1. So you have to select, first you decide what is F1 and F2, then you take a high pass filter with F1 and low pass filter with F2. Okay, so let us explain this with the help of a problem. Okay, so let us take down the problem. It is design a wide band pass filter with FL 200 Hertz and FH is 1 kilohertz, and a passband gain of 4 and a passband gain of 4. So, and also find quality factor. Okay. So here what you have to see, the response should be, finally the response should be, this is what we want. So a response will be, so this frequency is given is 200 and this one is 1 kilohertz. So this is FL and this is FH. So first what you have to do is you have to design a first order HPF with cutoff frequency FL equal to cutoff frequency 200 hertz. Then you cascade it with an LPF with cutoff frequency 1 kilohertz. That will, output will be the band pass filter, and since it is cascading or multiplying, the gain of H pass filter, total gain should be 4. But if you are using 2 stages, first stage let it be gain 2 and second stage 2. When you multiply, the total gain of the band pass filter will be, since you are multiplying, it will be 4. So you have to select design a high pass filter with this cutoff frequency, low pass filter with this cutoff frequency, and gain should be 2 both. Okay, let us design first a high pass filter L is 200. So we know how to do that. Let me select 0.05 microfarad, then your R will be 1 by 2 pi FL into C. So if you substitute and write, it will be 15.9 kilo ohm, and gain should be, that is RF divided by R1 1 plus, this should be equal to 2. So that means RF is equal to R1 equal to this you have to take 10 kilo ohm, let us take. Similarly, low pass filter you have to design, where you again select capacitor, we will call it is C dash, because we have used that symbol itself. Just see here, low pass filter C dash R dash we have considered. So C dash, let it be 0.01 microfarad, and R dash will be 1 by 2 pi FH into C. So that you substitute, you get here also you will get 15.9 kilo ohm. Okay, and gain again 1 plus RF dash divided by R1 dash should be 2. So RF dash equal to R1 dash equal to 10 kilo ohm. Okay, so and total gain also we obtained. So if you do this one, you will get a gain of 4. Gain is 4, and at cutoff frequency, one cutoff frequency is FL and another cutoff frequency is FH, where the gain will be maximum 0.707 times the maximum, 70% of the maximum you will get at the cutoff frequencies. And roll off will be, this roll off, if you see in the dB scale, I have plotted here linear scale, dB scale if you take, it will be here plus 20 dB per decade, and here it is minus 20 dB per decade. This is in the decade scale, okay, not in the linear scale, in the decade scale. This is how you design a band pass filter. And if you want to, the question is, you have to find the quality factor also. There is one formula you have to use, quality factor. So quality factor is nothing but it is calculated like FC divided by FH minus FL, where FC is the center frequency, but that can be calculated like this by taking square root of FH and FL. So if you take product of FH and FL and find the square root, you will find the FC. So for this one, it is 200 into 1000, its square root. So you have to just find that one, what is the FC, and that value, whatever value you get, that value should be divided by into 1000 square root divided by 1000 minus 200. So this is nothing but the quality factor. You calculate this. This I will give it as a homework. You calculate. FC is, this is the formula you should remember. FC is nothing but square root of FH into FL. Finally, if you want to calculate the gain of this one, so gain you want to plot, then what you have to find is, you should know the gain of the low pass filter multiplied by gain of the high pass filter. So low pass filter gain, so I can write gain LPF, gain of HPF. So this we already found LPF, low pass filter we know that is nothing but AF1 I will, or AF and AF dash will take. This I will call AF and this is called AF dash. So but in the bottom, in the denominator, it will be 1 by F by I think first we will find both are same, HPF or LF. This we will call AF dash, LPF, and high pass we will call AF. So this will be F by FH square. Okay, this is the first, and second one you have to multiply AF into low pass filter, sorry, high pass filter. High pass filter is square root of 1 plus F by FL whole square. This you have to multiply. So this you multiply, you will get the gain. You know the gain of in a single order or first order low pass, and you know first order high pass. It will be easy to calculate this. So each gain here, AF dash is 2, AF is 2, together it will be, you have to multiply 2 into 2. I think sorry, here I have missed one thing. You have to write F by FL. In the high pass filter you get this also. You just check that in high pass filter, gain of high pass filter is nothing but AF multiplied by F by FL. So it is there, I forgot that, sorry. So this will be the total gain. Okay, so this is about the band pass filter.